All right, guys. Somewhat new material today. We're going to get into interpreting graphs. And before I got to do it, I don't know what it is about the word interpreting, but I have to say it like Wolf Castle from The Simpsons. So if you're a Simpson fan, and I know at least one of you are, think of it like this whenever you're doing it. All right. I'm not going to waste too much time on my really bad impression. Let's move on. Now, I keep telling you guys all the way through that numbers and math and all that sort of gobbledygook means absolutely nothing if you can't relate it to something that's happening in the real world. So let's try and relate this to some imaginary thing that's happening in our imaginary real world. Okay, have a look at the graph. What does the line on the distance time graph represent? So the instant that we're talking about a distance time graph, hopefully you're thinking speed. If not, the fact that it says velocity in there should give it away, but we're looking at speed. Of course, I am making the assumption that you know what the word velocity means. Now, what is the rate of change? In this case, I'm asking you to find what the speed is, right? If we're trying to look at the difference in distance compared to the difference in time, we're looking at speed. So same as always, draw a triangle. Hopefully your triangle matches the grid lines better than mine does. The disadvantage of writing on this stuff, I'm a lot more accurate on my full smart board. What does that go over? 1, 2, 3. It goes up 1, 2. So 2. Ooh, this guy's going slow. 2 kilometers in 3 hours. That is distressing. I think most of you could crawl faster than that. Determine the formula for this relation. Since we're looking at distance, and we know that our rate of change is 2/3, so it goes in for m. What we don't know is how long we're traveling for. Now, whenever we're making up an equation, we got to remember to define our variables. So d is for distance, and state the units. Okay, squiggly, kind of looking like an N sort of thing. That's supposed to be an M. And T is time. In this case, times. Ooh, multiple. Let's get rid of that. Per hour. Now, I'm fixing up fewer of my mistakes as I go along because I've discovered that if I flip my screen right over and work on this as though it's a tablet, my handwriting comes out nicer, but it means that if I do make a boo-boo, it's a permanent boo-boo until I come back and fix it. So I hope that is a trade you guys are willing to live with. All right. What does it all mean? As I was saying before, graphs are meant to represent real-life actions. So the whole point of today's lesson is to try and get you to take a graph and relate it to what's actually happening, or take what's actually happening in our imaginary story that's happening on your page and make it into a graph. Okay? Probably the easiest one to visualize this is with speed, because every one of us has sped at some point or another, or at least been with our mom or dad while they've been speeding down the road. We all understand the concept of moving. So here's the scenario. At 11 o'clock, Micah's mother is sending him to the corner store and tells him to be back in 30 minutes. The store is 600 meters from his home. So let's have a look at the graph. You'll notice it's broken up into sections, so each straight line has an identifying point. So this first section here can be referred to as AB. Why are some line segments steeper than the others? So why is this line here less steep than this line? What's the difference? And in this case, because it's a speed graph, the steeper the line, the greater the rate of change, it means they're moving faster. All right, calculate the rate of change for each of the line segments. So segment AB, BC, CD, go back to, oh, not that graph, go back to this graph and do it. Hopefully you've printed up the handout at home, so this is a little less of a pain in the butt for you. Give you a second to do it. Okay, there's your second. Hit your pause button. Here's what you should have gotten. Ooh, and I'm going to rifle through these. I would expect you to spend a little bit more time on them. 50 meters, not kilometers this time. And notice we have to use min, not m, because we can't have m over m's. That would be tasty, but also confusing. Notice on the part where he starts coming back, so we have that negative slope, it means that he's moving in the opposite direction to what he was before. So that negative sign, which used to just be there to drive Cecilia crazy, is now actually has a meaning to it. It's giving us a sense of direction. If we're defining away from the house as positive, then coming back to the house must be negative. Seven. Oh, and after I told you guys you can't do it, I went and did it. All right. So what interval is Micah traveling the fastest in? And the hint that I got us at the bottom is its steepness. Whenever we're talking fastest, we're talking strictly about speed. So think about your speedometer driving down the road. If your mom or dad guns it, because you best not be driving yet, and they're doing 20 kilometers an hour forward, yes, that's gunning it. Or they kick it into reverse and they gun it, and it's 20 kilometers per hour backwards. The speedometer doesn't differentiate between positive or negative. It just recognizes it's 20 kilometers an hour. So all we got to do is look for what number is the biggest. And in this case, 50 wins. Although that negative 41.67 was close. How long did Micah take to reach the store? I don't know. I got my answers, but let's have a look, because this is a fairly easy one to look at. So we were told in the beginning that the store was 600 meters away, and we follow that line down 16 minutes. And how do I know? You are not allowed to say because my teacher told me so on the video. Actually, pretty much what I said is the answer. The store is at 600 meters and gets to 600 meters at 16 minutes. Okay, so it's not just a random guess. There actually is a reason why it's doing that. How long did Micah stay at the store for? Well, let's find out. And in human terms, he stayed at the store. In mathematical terms, he's not moving. Now, realistically, he's probably moving around the store, but we're not getting too fussy about that. He was there for 4 minutes. I don't know, bought himself a lightsaber or something. How long did it take Mikey to get home from the store? Have a look if you haven't already. How can you use your graph to tell which direction Micah is traveling? I've already talked about this one. So positive slope means he's moving away from home. He's going towards the store. Negative slope means he's returning home. And how do I know that's true? It's how the variables are defined. So, one more. Right? This is defined as distance from home. So as the distance from home is increasing, he's moving away from the home. As the distance from home decreases, he's heading back. Okay? So if you're ever not sure, you have to look at what the scale is on the graph. Did Micah make it home in 30 minutes? No, he was a naughty monkey. Gets to D equals 0 home at 40 minutes. So he spent too much time chatting up the girls in the store. Now I'm gonna. Well, no, I guess I will do that. All right. So using the information that the graph provide, write a story that describes Micah's trip to the store and back. Now this is a little hard for people. It can be any story. So, for example, maybe he was walking. He was walking pretty quick to get there. Ran into a friend of his, slowed down to walk with his friend, and then when his friend peeled away, he sped up again to get up there. Maybe he was walking fast and then saw a cat and slowed down to look at the cat and see what the cat was doing. When he lost sight, that's when he moved on. It doesn't really matter, okay? I don't know, maybe he was walking down and his hoodie fell in front of his eyes and he couldn't figure out how to get the hoodie out, but he wouldn't stop walking. That was dedication. You don't know, okay? You just don't know. I will come back afterwards and write a story on there that will give you an example. I don't want to really do it right now because it's going to take a lot longer for the video, and if you want to move on or not use up your data, then we got to move on. All right, so create a graph to model the following story. Alice lives 1 kilometer from the school. She was walking home one day at a leisurely pace. No idea what leisurely is. We just know that it's slowish. We're not rushing. All right, we're trying to look cool. After 10 minutes, she realized that she'd forgotten her cell and ran back to get it. So she was at the school for 5 minutes, and then she walked home at a quick pace. Now, the pain in the butt with this thing is that there is no scale. So we kind of got to make things up. We know that it's 1 kilometer from the school, so we're going to say 1,000, and we'll call that 500, which makes this should be 0, but it's home, it's school, distance from home, meters. And I don't know why I had that first bracket there. I'll put the second bracket there just to be complete. So we're starting off at school. She starts walking home. And after about 10 minutes, she realizes that she's forgotten her cell and ran back to get it. So notice the steepness of my line. My running back has to be steeper. We don't know exact numbers, so we just know that it's faster, so it's got to be steeper. Whoosh, she made it back, huffing and puffing. She was at the school for 5 minutes, so we got to have a little bit of a flat area. And then she walked home at a quick pace, so it's no longer leisurely. It's steeper than the line that we had. So we know the whole trip is 45 minutes. Yes, I am kind of making up my scale to make things match. Ooh, this one's not writing well. All right. So it's going to look something along those lines. Okay. I'm not super fussy about the numbers in here. If I want it more detailed, then one of two things will happen. I will either give you more numbers to give me specific values, or I'll provide you with a grid so that you can make a well-defined scale. This was just meant to be a quick little, here's an introductory, check it out kind of thing. All right. So here's your homework in the textbook. As you probably noticed, there is homework here as well. This is all on the handout that you could have printed up from my website. And if you want to stick around while I'm writing out my sample story, you go right ahead. But otherwise, you are welcome to get along, little doggy, and get some work done. Have a good one. Okay, that's as far as I'm going to go with this. If you're still with me, then thank you for sticking around with me. And this is one that a lot of open-ended questions. I know people are going to have troubles with it. You're welcome to contact me. Have a look at the full solutions. Good luck, guys.